Hey there, fifth graders. It is time for some science, and so far in our structure and properties of matter unit, we have learned a ton. We're now going to take all that we have learned and kind of get it written down so that we have that information available to us in our science journals. So you're going to end up taking these 2 sheets, completing them with me now, and you're going to either tape or glue them into your science spiral. So the first one we're going to do is this first sheet. It'll say Unit, Structure and Properties of Matter, Lesson 1, the Basics of Matter. We're going to fill in these blanks together. All right. Matter is anything that has, what are the 2 things that matter has? Matter has mass and it has volume. The measure of how much matter something contains is that item's mass. A lot of people think about how heavy it is, but it's how much matter something is made up of. And the amount of space something takes up, that's its volume. So matter has mass and volume. Mass is how much matter is in something, and volume is the amount of space that something takes up. The volume of irregular shapes is measured by using, so irregular shapes mean if I said, what shape is this? You wouldn't be able to say, oh, that's a cylinder, or oh, that's a rectangular prism. It doesn't have a name, it's irregular. And what we did in class, what we used was called water displacement. It's kind of nice if at any time I go too fast, you can always press pause. When you're using water displacement to measure volume, you're gonna have a certain number of milliliters along the side. Volume's not measured in milliliters, it's measured in cubic units. So for every 1 milliliter you have, that's equivalent to 1 cubic centimeter. That'll be important because when you go to do your reading and give out your answer of what the volume is, you're not gonna say the number of milliliters, you're gonna say the number of centimeters cubed. So how does water displacement work? What did we do? Well, first we took a measure of a known amount of water, right? We put some water in the graduated cylinder. So measure a known amount of water. So we filled it up and we looked at how much was in there, right? So step 2, what do we do? Well, we placed the item that we wanted to measure in the graduated cylinder. So step 2, place item in graduated cylinder. All right, then what did we do after that? We measured the water again. And when we went to figure out what our volume was, we had to subtract, right? And what did we subtract? Well, we took our new amount that we just got, so I'm gonna call this new, and we took away our original measurement, so I'll call that old. New minus old gave us the volume. And then we took however many milliliters that was and changed that into cubic centimeters instead. So your new measurement minus your old, that's just the difference between them. That gives you the volume. Okay, so that's when you have an irregular shape. We looked at some regular shapes. In particular, we looked at rectangular prisms, which that's what this is right here. So it's like 3D rectangles, okay? And we learned that there's a formula to be able to figure out the volume, like how many little cubic units it takes to fill that up. So if you have a rectangular prism, instead of dropping it into the water and using water displacement, we learned that you could just take the length times the width times the height to get the volume, to get how many cubic units will fit inside. So an example of that here, I have length of 6, width of 2, height of 4, and we're gonna multiply those 3 numbers together, so the volume is gonna equal 6 times 2 times 4. You can multiply those in any order that you want. Those properties in math work in science too. It's great. So when I look at 6 times 2 times 4, I would rather do the 2 times the 4 first, which I'm allowed. So the volume would be 6 times 2 times 4 is 8. And then I can do my 6 times 8, so 48. Now I wouldn't just say 48, right? I need to put the unit of measure. This was really 6 centimeters times 2 centimeters times 4 centimeters. And when you have centimeters times centimeters times centimeters, that means centimeters cubed. So 48 centimeters cubed would be the volume of that rectangular prism. So if it has a formula, you can use a formula. In 5th grade, you're only responsible for the rectangular prism formula. Later on down the road, when you're in middle school, you're going to learn some other formulas as well. All right, we also have been talking about the 3 states of matter, and I feel like we've been talking about those for a long, long time. We know that matter, pretty much everything's made of matter, right? Anything that has mass and volume is matter. And the 3 forms that you'll find matter in: solid, like us, right? We also can find matter in the form of a liquid. And we saw in class with the balloon experiment that it can also come in gas form, because we saw that air has mass and volume. This part here we haven't discussed yet, and it's going to lead us into what we talk about today. So, blank are the smallest pieces of matter. Atoms are the smallest pieces of matters. Okay? Now, atoms are actually made up of protons, neutrons, and electrons, and that's not a 5th grade topic. You'll learn about that later on. But atoms are made up of, we'll call them particles. Meaning protons, neutrons, and electrons, but again, you don't have to know that yet. And when you have some groups of atoms that have bonded together, that are kind of linked together, those form molecules. It looks like molecules, but it's not, it's molecules. Okay, so that's your first page. This is gonna end up going on, I think, page 19. You're gonna tape this into your spiral. And now there's one more sheet that you need that looks like this. Unit 2, Structure and Properties of Matter, that's what we're in. And Lesson 2, Energy and States of Matter. So today we're just going to talk about the states of matter. We'll talk about energy in that either tomorrow or probably on Monday. So let's get to it. These right here, you may have noticed, solid, liquid, gas, those are the 3 states of matter, right? And we are going to define them. We're going to give some examples of them, and we're going to draw out what the particles that make it up look like. Sorry, I'm trying to get this so I can fit it all in there. I might just have to scooch it. All right, so first off, the definition of a solid. Okay, like I have a stapler right here, right? This is a solid. A solid is a material that has definite shape and volume. So a material that has definite shape and volume. Okay, some examples of a solid. I just showed you a stapler. I think it's that. Okay, stapler. What else? What do you think? Ice. That's a solid form of water. What do I have in my? Oh, an apple. That's in my lunch. And why don't you go ahead and list 2 more of your own examples of solids? Okay. We're going to come back to the particles in just a second, so jump back up to the definition of a liquid. A liquid is a material that has definite volume, but as far as the shape goes, it takes the shape of its container. So a material that has definite volume but as far as the shape goes, it takes the shape of its container. So if you had 2 different shaped glasses and you started with 1 glass of water, if you pour that water into the other glass, it will then take the shape of that other glass. Some examples, I just said water, right? Let's see, how about some juice? Juice is a good example. Milk. And why don't you go ahead and give me 2 more examples of liquids? Okay, and again, if I'm going too fast, just pause it, okay? I'm gonna keep going because I only have about 7 more minutes before the kids come back. Okay, so gas. A gas is a material with no definite shape or volume, okay? You can't see what the shape of it is, and it's kind of invisible, so very difficult. So a material with no definite shape or volume. As far as being contained, like that the shape of a solid stays that. With water, it takes the shape of its container. With a gas, it expands to fill a container, just like the balloon I blew up in class. It expands to fill a container. Okay, so we need some examples. We had oxygen and carbon dioxide. Carbon dioxide. I always get someone that says fart or burp. If you want to write those down, you can. Those are examples of gases. It's fine. I'm fine with just those on there for now. You could put carbon monoxide if you want, but there we go. Okay, now the description of the arrangement of the particles. So we said that atoms are made of particles, and atoms are the smallest pieces of matter. So matter is made of atoms, atoms made of particles. And when you have a solid, basically you have particles that are super duper close together that don't move freely, that makes the object keep its shape, okay? So for the description of the particles, you're going to say particles are close together, they do not move freely. They're close together, they don't move freely. So here, a drawing of what the particles would look like. We're just gonna make our particles circles, okay? And in a solid, if I was gonna use this entire box right here to show what the particles would look like, I would have a whole bunch of particles that were all touching, and they're super duper close together, and it is so crowded in here that none of these particles can move. So when I check this in, I should see that you have a ton of circles all jammed together in this little box. This is what the particles of a solid look like. Liquid's a little bit different. If I put this stapler into a container, it's not going to take the shape of its container, right? Those particles are so close together that they don't lose their shape. In a liquid, the particles are farther apart than a solid. Particles are farther apart than a solid. And they move more freely. That's what allows them to change their shape. Okay? So in the particles here, we're going to have particles that there could be a couple touching, but they have space to move around. Okay, they can move so that when you pour them from one to the other, they can change shape because they're not so stuck together. Okay, finally, the particles for a gas, the particles are not held together at all. Particles are not held together, and they drift apart. So with this, you might see just a couple in here. They'll expand to fill their container, but they're not touching at all. They're very free and are able to drift apart. So way different than a solid. All right, so you are going to go ahead and tape or glue this in to page 20 in your spiral. And you are all set for science today. Thank you so much for watching.